So the next ones we're going to look at then are still parallel plates and charged particles, but now we're going to be sending them into there with some speed perpendicular to those field lines, and then we're going to watch as they curve either upwards or downwards, and it turns out that the particles then will follow a projectile path. Now, depending on which is the positive and negative plate and whether the charge moving into them is positive or negative, the motion could be net upwards or net downwards. And so the net motion will always be the direction of the force electric. The force of gravity will often have an impact on it, but it's not going to determine the direction ever. So if we start just for a moment, we take a negative particle here and we shoot that negative particle in between those plates. What we'll see is that negative particle is going to feel a force of attraction to that positive plate. And so what we're going to get is we're going to get a curved projectile path, and it'll be heading upwards. Now it might get to the end of the plates, it might not. Depends on how strong that electric field is. But if we look at kind of any point along here, we'll have then that force electric pulling upwards towards that positive plate. And then we will have then this force of gravity pulling downwards on it. Now, your force of gravity is always down, the force electric depending on the plates, and the charge, of course, could be in either direction. For this one here then, my net force, which is in the upwards direction, will be equal then to that force electric, but then I'll subtract that force of gravity just because those two are going in the opposite directions. Now, if I'm looking for a positive charge, it'll kind of move in the opposite direction. It's going to be attracted to the negative plate, still following though a projectile path, but just now a little more similar to what we did with our gravitational ones last year, going downwards. We can look at any point along here. Now here the force electric is pulling downwards, and so in this case that is going to be in the same direction as that force of gravity. I'll draw that arrow smaller because the force of gravity will always be smaller than the electric force. Our force net in this case is going to be pointing down, so I'll use that as my positive direction, and that will be equal then to the sum of those two. And so in this case, if they're working opposite, the force of gravity will take away from the overall net force. Here it'll add to it if those ones are going in the same direction. Now what you will notice as well is that anywhere along this path, for either of those, the force electric and the force of gravity remain constant. The force electric is constant because the electric field is the same everywhere here. The force of gravity is constant because the mass is the same everywhere. And because it's a constant force all the way through, that does make it a projectile motion question. Now when we get into magnetic fields, we'll look at circular motion questions, and the difference between those, because again the path length does always look this, or often look the same. In a circular motion question, that net force vector is constantly changing and always pointing towards the center of the circle. That will be with magnetic fields. For electric fields, we get this projectile path because the direction of those forces then remain constant. So these will be similar to what we did in Physics 20. We're only going to do the horizontal launch ones here, so that will simplify things a little bit when we do that. But keep in mind when we're doing that, there's no forces horizontally. Now there was obviously some force getting the particle moving, but we're looking at it from the point when it's already moving. So as it's traveling through here, there are no horizontal forces. That means that we have uniform motion for our horizontal component, and we have just one equation then, velocity equals distance over time, then that gives us that horizontal component. Our vertical component, though, we will always have some force, either a net up or a net down, and so that will be different. In Physics 20, we only looked at downwards forces because it was gravity. Here you do have to choose the direction either going up or going down. But because we have that net force, this is non-uniform motion. And with the non-uniform motion, we have four equations that we can use. These top two are going to be the more common ones, but you can use any of those four equations to describe then the vertical speed. Don't forget, because these are horizontally launched, for all of the ones we're doing here, my initial velocity in the vertical component will be 0 meters per second. So again, these are similar to the projectile motion questions we did in Physics 20. The one difference there with these ones here is we're going to have to first calculate what is the acceleration. So last year, the acceleration was always 9.81 because it was just gravity. Here it's the electric field providing that, so we're going to have to do a net force equation like we did up here, and then remembering that force net is equal to mass times acceleration. We can take that force net equation, solve for the net force, divide by the mass, and that will give us our acceleration. Now for things that are larger, things like oil drops, we do have to account for both the force electric and the force of gravity. For subatomic particles, because they're so small, the gravitational force is really kind of irrelevant. Now you can add it in, it's just not going to make a difference, but if it's one of these three particles here, so your alpha particle, your electron, your proton, the neutron won't count because it doesn't have a charge, so it won't interact, it'll just go straight through. But if it's one of these three here, you don't need to include gravity. Again, you can include it, it's not going to change your answer, but you can leave it out. If it is an oil drop though, which is another common case for these, then make sure that you are including the gravitational force because it will make a bit of a difference.